Okay. This is this an equivalence relation? Well, it's definitely um, reflexive. You can say x equivalent to x. That is if and only if x is more than or equal to x. So that's true. Is it reflexive? So x equivalent to y is the same as saying x is greater than or equal to y, but y equivalent to x, that is the same, is saying that y is greater than or equal to x, and they're only the same thing if x equals y, so it fails symmetry, so no good for that one. B, two integers are equivalent if their product is positive. So is x, well, I should use m, maybe is m equivalent to m? Well, I mean, uh, sorry, I knocked something over here. That's interesting. I think this is no as well, because I can just give an example. Like 0 is not equivalent to 0 because 0 is in z, but 0 times 0 is not more than 0. So it's failed symmetry, or it fails being reflexive. So that's a no as well. C. Okay, so it's firstly, we can do this because that's obviously true because it's 0. And I know we can do this because x equivalent to y means x minus y is less than or equal to 4. But I know for absolute, you can swap it around. It's still true. So that's that. But the tricky one is transitive. So that is transitive. That's tricky. A number line might help me here. So x and y are equivalent. So like there's x, there's y. If the distance between them is less than or equal to 4, and then let's say y and there's z, and y and z are equivalent if the difference between them is less than or equal to 4. But of course, that doesn't mean the difference between x and z is less than or equal to 4. So if I give an example, a counter example, I can prove it fails. Just a second. So you could see, for example, 1 is equivalent definitely to 4 because 1 minus 4 is less than or equal to 4. And 4 is equivalent to 7 because 4 minus 7 is less than or equal to 4. But 1 is not equivalent to 7 because 1 minus 7 is not less than or equal to 4. So yeah, that's another one that fails. So finally, D. M congruent to n in z if m congruent to n modulo 6. So let's see if it's reflexive. So M, is that equivalent to, well, we have the symbol here, but is M equivalent to M? That means M mod 6, M minus M. Does 6 divide into that, basically? Does 6 divide into 0? I guess technically yes. Now, what about M n? That means M n mod 6. So that means 6 divides into M minus n. But since we're in the integers, we can say 6 divides into n minus m will just be negative for the previous one. So yeah, that leads us back to the other direction. So I think the trickier one now is transitive. Let's see if we can get transitive. Okay, so we'll say A equivalent to B. So what that means is A equals B mod 6, which means 6 divides into A minus B, which means A minus B equals 6P, where P is an integer. And then B mod 6, B equivalent to C, that likewise, that would mean B minus C is equal to 6Q. So does that lead to AC? So if I were to add these results together, I would get A minus C equals 6P plus Q. C, not 6. A minus C equals 6. So that would mean that 6 does indeed divide into A minus C. So that would lead us to A congruent C mod 6. So that looks like it's transitive. So as far as I can tell, only the last one is. Let me check. Yeah, that checks out. They all fail, and the last one, I believe, is.